everybody. In this video, we're going to talk about the permutation and combination formulas. So take 3 deep breaths and let's make this math easy. All right, so before we jump into the permutation and combination formulas, I first want to just say that I actually don't ever use these formulas because I find it much more useful to think about in my head what the choice tree would look like and to write a mathematical statement that describes that choice tree rather than trying to use these formulas. However, you do have the formulas available to you on the reference sheet, and it may be helpful for some of you. So I want to explain where these formulas come from and how you calculate them. So the first thing we need to know in order to understand the formulas is to know what the factorial symbols mean. So if you see this symbol here, if you have 5 factorial, which is represented with like a little exclamation mark, what that means is you're going to do 5 times 4 times 3 times 2 times 1. And essentially you're going to multiply it by each receding number until you get down to 1. So like 12 factorial would be 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, etc. So that's what a factorial means. And the permutation and combination formulas are written in terms of factorials. So let's look at the permutation one first. So remember, permutations are where the order does matter. So this would be an example like choosing a president, then a vice president, then a secretary. Versus combinations are where order doesn't matter. So that would be like choosing a committee of 3 people, but you're not saying that one is the president, one's the vice president, or one's the secretary. So that's the difference between permutations and combinations. And with permutations, let's say that I was choosing k things from n different options. In that case, the number of ways that you can do that is described with this formula. And I think it's a little bit easier to understand this if we look at it in an example. So let's say that you wanted to choose 3 people from 15 people. Well, based on what we've done before, we know that we could calculate this by figuring out how many branches there are in the choice tree, which we could do as 15 times 14 times 13, because there's 15 choices for the first person, 14 for the next, 13 for the third person. And then, because the order does matter, we're not going to divide by any duplicates. We're just going to let it stay like that. So we know from our choice tree practice that this is what the calculation should be. And if we were to use the formula to calculate this, it would give us the same answer. Because in the formula, k represents the number of things you're choosing from n options. So in this case, k would equal 3 and n would equal 15. And if we write out this calculation based on this formula, we're basically going to be doing 15 factorial divided by 12 factorial because n is 15 and n minus k, or 15 minus 3, would give us 12. Now, if we write out the calculation for this, we'd have 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That would be 15 factorial. And then 12 factorial would be 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. This would actually be how you would calculate out the permutation formula. But if you notice, almost all of these factors cancel each other out because 1 divided by 1 is 1, 2 divided by 2 is 1, 3 divided by 3 is 1, 4 divided by 4 is 1. And basically all of these matching factors are going to cancel out and you end up with the exact same calculation that we did with the choice tree. So this is one of the reasons why I don't like using the formula. I like just thinking about it as a choice tree, because the formula makes me write out all of this stuff and then cancel out the common factors, versus if I just think about what the choice tree means, I can just list out a short calculation. So you guys are welcome to use the formulas if you would like, but I actually think it's a lot easier if you don't use the formulas. And we'll quickly go through the combination one as well, but it's very, very similar, because if you notice, this part of the permutation formula is the same as this part, and the only thing that's new is this division by k factorial. But basically what that's doing is that's dividing out all the duplicates. Because if the order didn't matter, we would still have 15 times 14 times 13 options when you choose 3 people from 15 people. But the number of duplicates we would have would be 3 times 2 times 1, which is what that k factorial means. And so, again, I don't think that it's easier to use the formulas. I think it's easier to just list out the choice tree calculation and then divide by the duplicates if you need to. But you're welcome to use the formulas if they're helpful for you. And if you have any questions, please let me know.